Hey guys, welcome to my channel again. In this video, I'm going to walk you through an example of finding the inverse of a square 3 by 3 matrix. Unlike most of other videos on this subject, I'm going to use a method of the so-called a stack of transpose matrices. In any case, I'm going to show you easy steps to follow. So let's get started. Let's have an example of a square 3 by 3 matrix. And let's call it matrix A for our purposes. And here are the numbers. So we're moving on with the first step. Calculate the determinant of the matrix. I'm going to use the Saros rule in order to calculate the determinant of a square 3 by 3 matrix. If you want to know how the Saros rule works in detail, you can see the reference site below. In applying Saros rule, we need to copy the first two columns of the matrix and use them as the fourth and the fifth column respectively. There you go. And then we need to calculate the sum of the products along the downright diagonals as represented by the yellow arrows. And here are the numbers. And then we also need to subtract the sum of the products along the upright diagonals as represented by the red arrows. There you go. Alright, we've got here all the sums of the products of all the diagonals. And we have calculated the determinant of matrix A, which is 70. So we're moving on to the second step. Create the transpose matrix. And as you can see, we've got A transpose matrix on the right hand side of the caption, as symbolized with A with a superscript T. So matrix transposing is actually columns in the initial matrix becoming rows in the transpose matrix, and rows in the initial matrix becoming columns in the transpose matrix. So here, the first column in the initial matrix becomes the first row in the transpose matrix. And the second column of the initial matrix becomes the second row in the transpose matrix. And finally, the third column of the initial matrix becomes the third row of the transpose matrix. There you go, guys. We've got here the transpose matrix of our initial matrix A. Okay, guys, we're moving on to the next step, which is actually a key step in this method. Step 3. Create a stack of 4 transpose matrices in order to form 2 transpose matrices on top of the other 2. So here is the first transpose matrix. And here is the second one side by side with the first one. And we've got the third transpose matrix below the first one. And here is the fourth transpose matrix below the second transpose matrix and side by side with the third one. Remember, we need to stack the transpose matrices all together exactly in the format like this. Alright guys, we're moving on to step 4. Exclude the most of the rows and columns of the stacked transpose matrices. This is actually another key step in this method. So we simply need to leave out of sight the most of the rows and columns of the stacked transpose matrices. There you go. Here is the resulting format of numbers after the removal of the most of the rows and columns of the stack of transpose matrices. From this point onward, we need only to focus on this format of numbers. And then we're moving on to step 5. Cluster the remaining numbers into 2 times 2 submatrices. So let's start with the first 2 times 2 submatrix in the upper left corner of the numbers. And moving on to the second submatrix and the third one in the upper right corner. And here is the fourth one, the fifth one, and so on. And finally, here's the last 2 times 2 submatrix. In total, we have 9 2 times 2 submatrices. We're moving on to the next step, step 6. Calculate the determinant of each of the 2 times 2 submatrices in order to form the so-called adjoint A. As I mentioned before, first we need to calculate the determinant of each of the 2 times 2 submatrices, and then we need to put the resulting determinants as the components of the adjoint A matrix, as you can see here on the right-hand side of the caption. And as you can recall, I'm showing you here in the box the formula of the determinant of a 2 times 2 matrix. Now we can start the calculation of the determinant of each of the 2 times 2 submatrices. And here is the first 2 times 2 submatrix. And we can put the resulting determinant thereof into the adjoint A matrix on the right-hand side of the caption. And moving on to the determinant of the second 2 times 2 submatrix. And here's the third one, the fourth one, and so on, and so on. And finally, here's the determinant of the last 2 times 2 submatrix, and we put the resulting determinant into the adjoint A matrix. Okay guys, we're moving on to the last step, step 7. Calculate the inverse matrix. And as you can recall, the formula of the inverse matrix is defined as 1 divided by the determinant of the initial matrix A times the adjoint A matrix. So the determinant of the initial matrix A, as we have calculated before, is 70. And here is the adjoint A matrix that we have composed before. And putting all the numbers into the formula, here is the calculation of the inverse matrix of our example. And here is the inverse matrix of our example of the initial matrix A. And finally, here is the resulting inverse matrix in simplified fractions. Right guys, at this point we have finished our example of finding the inverse of a square 3 by 3 matrix by using a method of a stack of transpose matrices. Okay guys, we can now summarize the steps we have taken in our example. So the first step is to calculate the determinant of the initial 3 by 3 matrix. The second step is transpose the initial matrix. Step 3. Create a stack of 4 transpose matrices in order to form 2 transpose matrices on top of the other 2. This is actually a key step in this method. Step 4. Exclude the most outer rows and columns of the stacked transpose matrices. This is actually another key step of this method. Step 5. We need to cluster the remaining visible numbers into 2 times 2 submatrices. Step 6. Calculate the determinant of each of the 2 times 2 submatrices in order to form the adjoint A matrix. And the final step, step 7. Calculate the inverse matrix. Alright guys, here's a summary of the steps we have taken in finding the inverse of our initial square 3 by 3 matrix. Remember, we have used the method of a stack of transpose matrices. Alright guys, we have reached the end of this video. Don't forget to subscribe, click on the bell button, and give a thumbs up to this video. Thanks for watching and see you next time.